All right, here's our practice test. So factor f of x is equal to 3x cubed minus 12x squared plus 12x. Use your factorization to find the zeros of the function. So remember, kind of look at these and see what you can factor out. So it looks like you can factor out a 3 and an x. Once I factored that out, what do I have left? I have x squared minus 4x plus 4. Now on that one there, you can kind of look at it. So you should see 3x, and then again, I have an x, and I have an x. I look at that term, it's positive. I look at that term, it's negative, so that tells me that they're both negative. And factors of 4 that add up to 4 or negative 4, it will be 2 and 2. But remember, you want to write that as 3x times x minus 2 squared. So it has a multiplicity of 2. And that is the one that will go into this box here. Right, so now it says list the zeros in order from least to greatest. So remember, we know that we have 3x is equal to 0 by the zero product property, or x minus 2 is equal to 0. Remember, we're going to have 2 of them there. So we'll have that x is equal to 0, or x is equal to positive 2. So we're going to say it's 0, it's going to be 2, and it's going to be 2. The polynomial f of x has degree 4. Choose any statement that could describe all of the zeros of f. So remember, when I'm talking about something like that, I can start with, say, x minus a raised to the 4th power. That would be 1 0 with a multiplicity of 4. Remember, what has to happen is the exponents have to add up to 4. All right, so let's see here. Well, this one's not going to work. That one's not going to work. Let's see this one here. 1 0 with a multiplicity of 1, so let's call it x minus a, and 1 0 with a multiplicity of 2, so that would be x minus b squared. Again, that's only going to add up to 3. So hopefully you get the idea. And so what you should see is 1 0 with multiplicity of 1 and 3. So those add up to 4. 1 0 with a multiplicity of 2 and 2 zeros. So that one will work. 2 zeros with multiplicity of 2, that one works. And finally, 4 zeros with multiplicity of 1. Again, think about that. That'd be x minus a to the 1st power, x minus b to the 1st power, x minus c to the 1st power, x minus d to the 1st power. So those are all the ones that you can have. Okay, remember, the key is that the exponents add up to the degree. Let's see, arrange the equations in order from the least to the greatest number of solutions. So least to the greatest, remember the number of solutions is look for the highest exponent. So on this one here, the highest exponent is 5. On this one here, it's 2. On this one here, it's 3. And on this one here, it's 6. So they want us to go from least to greatest. So if we do that, we'll have the, let's see, the smallest one is squared. Remember, I'm sure it's a drag and drop. Then we would have x plus 1 is equal to 3x cubed minus x squared. Then we'll have the 5th. And then the last one, of course, it's just going to stay the same. Remember, highest exponent is the key. Find all of the zeros of f of x is equal to 2x cubed plus 32x by factoring the polynomial completely. So kind of like we did on number 1. So let's see here, I can factor out a 2x. So if I factor out a 2x, I'll get what's left in parentheses is x squared plus 16. Remember, if this is a plus here, ladies and gentlemen, I mean, you can think about it, but the only way that's going to work is if I have x plus 4i and x minus 4i is equal to 0. So remember, by the zero product property, I'll have 2x is equal to 0. X plus 4i is equal to 0. Or x minus 4i is equal to 0. So this will be x is equal to 0, x is equal to negative 4i, x is equal to positive 4i. All right, so the real 0 is a 0, and the complex ones are negative 4i and plus 4i. They already put that there, so you just have to put 4i or whatever one you have. Number 5, write a polynomial function of least degree that has rational coefficients and a leading coefficient of 1 and the zeros 3 and 2i. So remember, if it has the zeros 3 and 2i, it also has the conjugate of 2 plus I, which is 2 minus I. I'm going to go down here and do it for you. So remember, what that is saying is our zeros are x is equal to 3, x is equal to 2 plus I, and x is equal to 2 minus I. All right, so remember, now I'm going to take this, and remember, we're kind of working backwards, so I'm going to use the zero product property thing. So remember, if I move that 3 over to the other side, it becomes negative. So I'll get x minus 3 is equal to 0. I'll get x minus, now put that in parentheses, 2 plus I is equal to 0. And we'll get x minus 2 minus I is equal to 0. So again, if we were to multiply them together, we would have this. We would have x minus 2 plus I, and then we'd have x minus 2 minus I. Again, that'll equal 0. So remember, my suggestion to you was to take these ones and regroup. That was what I had you do in your notes. All right, so if we're going to regroup, we should get x minus 3, and then we're going to have x minus 2 plus I times x minus 2 minus I. And hopefully you'll see that that is going to be a difference of squares. So on that one right there, again, what I can do is I can write this as x minus 3. And then if I FOIL this, all right, you should see that I'll have x minus 2 squared minus I squared. All right. So now if we remember that, we're going to go ahead and say let's go over to the side here. So if I have the x minus 2 squared is equal to x minus 2 times x minus 2. All right, so if we think about that, we'll have first terms x squared minus 2x would be minus 4x. And then we'll have negative 2 times negative 2, which is plus 4. So that's just for the x minus 2 squared. With the other part, what you have to remember is, but I squared is equal to negative 1. So then we're going to have x minus 3 times x squared minus 4x plus 4 minus a negative 1, which hopefully you'll see is 5. So now we're going to go and we are going to go ahead and multiply it the long way out. X squared minus 4x plus, again, negative times a negative is a positive, so that'll give us plus 5. And then I'll do x minus 3. And if I do that, let's see, x 5 times negative 3 is negative 15. I'll have 3 times negative 4x is plus 12x. I'll have negative 3 times x squared, which will be negative 3x squared. Again, remember I should take this one here and it should go down there. So 5 times x is 5x, and that one's positive. X times negative 4x is negative 4x squared. And then x times x squared is x cubed. And if we add that up, we'll get x cubed minus 7x squared plus 17x minus 15. And that is what you are going to put up here. So what do I say? X cubed minus 7x squared plus 17x minus 15. Okay. Number 6 here, ladies and gentlemen, is just kind of a gimme problem. Okay. So we know that k times x cubed so again, if we look here, when x is equal to 1, what's y going to equal? It's going to equal 4. So think of it as I have kx cubed is equal to 4. Our our x I just said was 1. So 1 cubed is 1. So that'll give us that k is equal to 4. Now check it just to make sure. If I take x is equal to negative 1, negative 1 times negative 1 times negative 1 is a negative 1, right? And negative 1 times 4 is negative 4. So that does work. So our k is equal to 4. Okay? If you're watching this, which I hope some of you are, this problem is exactly the same. All right? It's exactly the same because it was a benchmark. It did not let me change the numbers. Number 7, describe the transformation of f represented by g. Remember, if it's attached to the x on the inside, that's going to be a horizontal. And remember, it's going to be kind of the opposite. So 3 sounds like it's a stretch because it's a big number, but remember, since it's horizontal, it's the opposite, so it's going to be a shrink. And remember, it's going to be a shrink by what have I always told you to do. When I hear the word horizontal, I've told you to flip it. So that is going to be 1/3. And a translation, this part right here is just translation 5 units. And again, that is going to go up because it's not on the inside. Number 8, let the graph of G be a vertical shrink by a factor of 1/3, followed by translation 5 units up of the graph of f of x is equal to 3x cubed minus x. Okay, write a rule for G. Remember, I keep telling you your book likes to start with h of x. And remember, h of x, we're going to say is it's a vertical shrink, so that's going to be on the outside, so it's going to be 1/3 times f of x. So that means it's going to be 1/3 times 3x cubed minus x. If we distribute that 1/3 through the parentheses, we'll get x cubed minus 1/3 x. That's not my answer though, because there's two things that are happening. So g of x is going to be, again, it's a translation up or down. Up or down means it's on the outside. So we're going to take it and we're going to take whatever our h of x was and just add 5 since it's up to what we have. So our answer then will be x cubed minus 1/3 x plus 5. And that'll go here. So x cubed minus 1/3 x plus 5. Number 9, okay, again, on this one here, horizontal stretch, horizontal, again, the key there, ladies and gentlemen, I've said that last chapter, I've said it the chapter before, I'll say it the next chapter, and I'll say it in chapter 6. Whenever I hear the word horizontal, I'm going to flip it. So again, on here, our h of x, in this case, is going to be f of 1/3 x. Remember, I said I flip it and I attach it to the x. So on this one here, I'm going to take wherever I see x and I'm going to replace it with 1/3 x. So I'm replacing x with 1/3 x, and I'm cubing it, minus 2 times 1/3 x, and I'm going to have plus 12. All right, remember 1/3 times 1/3 is 1/9 times 1/3 is 1/27. So I'll have 1/27 x cubed minus, well, 2 times 1/3 is just going to be 2/3 x plus 12. Then our g of x, in this case, it's 2 units down. So again, if it's down, up or down, we're taking our previous one, which was h of x, and in this case, we are going to subtract 2 from it. So we're going to take our 1/27 x cubed minus 2/3 x plus 12. That was our h of x. And we're going to subtract 2 from it. So that will give us 1, that's cubed, 1/27 x cubed minus 2/3 x plus 10. And again, that would go over here. Number 10, we did a problem like this in the notes. Okay. When we did that, remember, same thing like we just did. Kind of, we're going to replace our x with 12x in v of x. So that means we're going to take w of x is equal to, they told us our function is that, so we're going to take, and we're going to take 12x, and we're going to be cubing that, minus 6, and again, we're going to take the 12x, and we're going to square it. All right, so if we do that, 12 times 12 times 12 is 1,728 x cubed. And then I'm going to have 6 times 12 squared. 12 times 12 is 144. So times 6, that will give us 864 x squared. And then it's asked us to, no, that's going to be too late. It's told us to then find W of 2. So W of 2, again, all we're doing is wherever we see x, we are now replacing it with 2. And if I work that out, I'll have 1,728 times 8 minus 864 times 4. Again, you could have just plugged all of that into your calculator, and you would have seen that you'll get 10,368. So the first one was W of x is equal to 1728 x cubed minus 864 x squared. And then this one was 10,368. On number 11, it says to plot the x-intercepts of the function 2x to the fourth minus 26x squared plus 72. You could probably look at it and graph it if you want, ladies and gentlemen. Again, or you can do something like this. Now remember, I told you an easy way to do this is to say let u equal x squared. So if I let u equal x squared, okay, all I'm doing is I'm replacing x squared with u. So x to the fourth should be a u squared. Hopefully you'll agree with me. So we're going to have 2u squared minus 26u plus 72. And again, we're looking for the x-intercept, so we're going to say it's equal to 0. Remember, on this one here, I can factor out a 2. So if I factor out a 2, I'll get u squared minus 13u plus 36 is equal to 0. So remember, then I could divide by that 2, so I'll get u squared minus 13u plus 36 is equal to 0. All right, let's go ahead and solve this one here. So we'll get u into u. Remember, this one's plus, so I look at that one. What are factors of 36 that when I multiply them, give me 36, yet when I add them, give me negative 13. And you would tell me, oh, hey, it's u minus 9 and u minus 4 is equal to 0. All right? So by the zero product property, we know that u minus 9 is equal to 0, or u minus 4 is equal to 0, or u is equal to 9, or u is equal to 4. But remember what I just said u was? U is equal to x squared. So you're going to tell me x squared is equal to 9, or x squared is equal to 4. Again, how do I undo a square? I square root it, so I'll put plus or minus 9, or x is equal to plus or minus the square root of 4. 9 is 3, so plus or minus 3. Or x is equal to plus or minus 2. So now all they wanted us to do was plot the x-intercepts. They're not asking us to draw anything. So we just said it was -3 and +3, -2 and +2. So good there. Okay. Use a graphing calculator to graph f of x is equal to 2x cubed minus 7x squared plus 5x minus 6, and find the following features of the graph. All right. So on this one here, you're going to have to kind of look at it because I'm going to have to go back and forth. All right. So I have it graphed here for you. 2x cubed minus 7x squared plus 5x minus 6. Now remember, what are they asking us for? They're asking us for intervals, all right, on which it is increasing and on which it is decreasing. And they want the local max and they want the local min, and they want the x-intercept. Notice there's only one x-intercept here. So on a lot of this, I would just click on it. It'll give you what it is there. And here's our local minimum, and here's a local maximum. And I don't really need this one here, all right? Because again, it's going to be asking us, well, which is our x-intercept? That one's an easy one to do. Our x-intercept is x is equal to 3. And then it wants us to find the intervals on which the function is increasing. Remember, it's the x values. All right, so if again I go back to this here, where is it increasing? It's increasing right here, right? So I'm going up, and I'm going up until right there, all right? So all of that is less than 0.44. So you're going to tell me it's less than 0.44. And I don't think you'll have to put the 0 there. Maybe you should, just to be safe. And where else is it increasing? If I go from here, I can see that it's increasing here. And where is that increasing? When x is greater than, again, they said to do it to the nearest hundredth. Remember, a hundredth is 2 decimal places. All right, so we know it's going to be at when x is greater than 1.89. Find the interval where it's decreasing. So the interval it's decreasing is right here. Again, if I'm following the graph, I'm going up, I'm increasing until I get to the local maximum there, and then I'm decreasing. So I'm decreasing in between those two. In between those two would be 0.44 and 1.89. Again, if you look at it again, what's our maximum? Again, now that's the point that they're asking us. So we're going to say 0.44 and negative 4.99. And then our local minimum will be 1.89 and negative 8.05. All right, so I just told you that. So it's going to be 0.44 and negative 4.99. And then we're going to have 1.89 and negative 8.05. All right, so on this one here, determine whether each function is even, odd, or neither. So remember, here's the easiest way to think of it. One of the things, if it's even, we know that f of negative x is equal to f of x. Okay? And it works if all exponents are even. All right? So which one has all exponents even? That would be this here, because both of those were even. So that one will go here. Okay? I'm kind of giving you a hint here, ladies and gentlemen. Again, here's the second one where, again, it was a benchmark, so I couldn't change anything. Hopefully you're paying attention, and you'll see that it's the same. So for it to be odd, so that was even, so let's change our color. For it to be odd, all right, we know that f of negative x is equal to negative f of x. All right, and that works if all exponents are odd. So if that's the case, let's see here. Remember, that's to the first power, so that's odd. And so this one here would be right there. The other two have an even and an odd. So both of those will go into this one here, because both of them will be neither. Okay, and you could work them out like we did on the notes, but kind of giving you another gimme here if you're paying attention. All right, number 14. Write the cubic function whose graph is shown. So remember, we can say it's f of x, take the x-intercepts and change them. So we know we're going to have an a that we have to solve for, and then we're going to have x plus 3, we're going to have x plus 1, and then we're going to have x minus 3. All right. Now we're going to plug in the other point we have. Again, I told you it doesn't always have to be an intercept there, but in this case it is. So if that's the case, then we're going to say 18, which is our y value, is equal to a times 0 plus 3 times 0 plus 1 times 0 minus 3, which will give us a, and then we're going to have 3 times 1 times negative 3, or we'll have 18 is equal to 3 times 1 is 3 times negative 3 is negative 9. And to solve for a, we're going to divide by negative 9, or we'll get that a is equal to negative 2. All right, so hopefully it'll let you keep it like this. F of x is equal to negative 2. Because I know on the homework we were able to. That's why I'm kind of curious. Because their answer here, they kind of made it a big one. So again, I'll have somebody look at it. All right. And hopefully that should work. If it doesn't work, multiply it out. All right. If it doesn't work, multiply it out. And the easiest thing to do is to take these two because they are differences of squares. All right. So we can write those as x plus 3 times x minus 3 is x squared minus 9. And then we're going to take our x plus 1. And again, you're going to have to kind of leave some room here because you need to think. So I have 1 times negative 9 is negative 9. I don't have an x term there, so I'm going to put a 0x there. And then 1 times x squared is x squared. Now that should work. So now I'll have negative 9x. Okay. And then again, I don't have an x squared here, so I can put a 0x squared there. And then x times x squared is x cubed. So that would give us x cubed plus x squared minus 9x minus 9. Multiply all of that by the negative 2. And your answer will become negative 2x cubed minus 2x squared plus 18x plus 18. All right. It's going to be one or either of those. I'm really hoping that it just stays this one because that'll make it easier for you. All right. And then finally, the last one, the table shows the value y in dollars of a stock on day T. Use the regression feature on a graphing calculator to find a quadratic model and a cubic model for the data. All right. So here's the thing I suggest to you. They tell you to do that, but I say, look at it. All right. And if I look at it, it's going to be this one here. All right, so I want you to look at that. Does that look like it's going to be a parabola? All right, you might have to zoom in or zoom out. But again, does that look like a parabola? And you should say no. So you should say, well, if that's not a parabola, we know that that is a cubic model. All right. So you're going to say cubic here. All right. And then they're asking us to enter the better fitting model and to round each coefficient to the nearest thousands. So that would be what? 3 decimal places, ladies and gentlemen. All right. So again, I went ahead and put in the whole thing here because I don't want to spend an hour putting all of this stuff in. And then remember, when you're here, all right, and kind of look how nice it fits it, all right? Remember, when you're there, you have to put the tilde in there and the x to the minus 1, all right? So remember, you kind of have to go, let me see if I can just put it here, and let me go, well, let's see here. Oh no. Whew. I thought I lost it there for a second. All right. So as always, this right here is in my way. And it's going to take away my thing. Let's see if I can do it. So there's our keypad. Remember, when you say Y, and then, let's see, can I get rid of that? Good, I can move that. And then remember your tilde is over here. So you're going to go here, and there's your tilde, and there's your A to the B. So you would go tilde, and then you would go X, A times X and then you press that one for the B. Okay? So remember that one, ladies and gentlemen. That'll help you. All right? So if I do that, let's see here. Can I show this now? Or did I screw it up? All right, I do have my list there. Well, looks like I'm going to have to do it here, ladies and gentlemen. So let's go ahead and get rid of that one. And we're going to go and do it ourselves. So we're going to say y, and we're going to go here. Oops. That's why. Darn it. So I'm going to delete that. All right. Well, that's okay. I'm going to show you how to do it anyways, right? So I'm going to say y, and then go here, go to the 1, because I need to put a 1 in there. Okay, that's not working. I don't know what happened there. Try it again. So y, tilde, and then we are going to, sorry, I'm not tilting yet. Until I'm getting tired. So y, then I'm going to go here. Now it went down, which is good. So I'm going to say 1. Okay. And then now I'm going to go tilde. And remember, since it's cubic, it's going to be ax cubed plus bx squared plus cx plus d. All right? So we're going to say a. Does a have a subscript? No. So we'll go x. Now x has a subscript, so we have to go back here to this one and go 1. And then, notice now it's coming up. Then we're going to go to this one here, right? Because now we need a cubic. All right, so it's kind of looking there, but it'll be nice here. So then remember, I'm going to go plus, and then I'm going to go B. And then I'm going to go X, again, sub 1. And then on this one here, I can go squared. Notice how it keeps moving. All right. And then I'm going to go plus. And then I'm going to go C. And then X. What do I have to do with that X? Because it's regression. That's the only reason I have to keep doing the sub 1. Okay. And then we're going to go plus. And then what's our last thing? D. Oh, never mind. Sorry, I forgot to tab it up. So now I'm going to go plus. And now I'll go D. So if you notice there, it looks pretty nice. And remember, the R squared has to be close to like 1. So that one looks pretty good. So again, it said to the nearest third, so thousandths. So that would be the third decimal place there, ladies and gentlemen. All right. So let's go back to this. And when I do that, again, if I follow what I said to the nearest thousandth, that would be 0.018 t cubed minus 0.297 t squared plus 1.430 t plus 6.324. And then it says on this, use the model to estimate the value of the stock on day 13 to the nearest cent. So remember on the other one there, they started us with t equals 1, but they didn't tell it. They told us that was a certain year. On this one here, we're just going to plug in 13, all right? Because they didn't tell us a certain thing. So if you plug in 0.1 times 13 squared minus 0.297, 13, that one's squared, this one is cubed, plus 1.430 times t, or 13, plus 6.324. If you plug that in, ladies and gentlemen, it does give you 14.267. But remember, if we're talking about money, money's only to the nearest one there. So again, I'm going to have to look at that, and that is going to make it be $14.27. All right, hope that helps you. If you look at this, ladies and gentlemen, you should be able to do really well on your test.